Okay, so the purpose of this tutorial is to kind of walk you through pretty much all the steps that you need in order to launch your own token and have it be something that you can list on, say, Uniswap or PancakeSwap or what have you. But if it's just about launching a token, there are a couple things that you are going to want to understand just before you jump into it, just so you really know what you're doing. Obviously, you know this, but when it comes to making these tokens, they're very easy to make, but they do have some real implications, real money implications. So you want to be safe with everything you do with these contracts. Most people start with Remix IDE, which if you go to remix.ethereum.org, it's very simple because you're not having to deal with, usually if you're just generating a token, you're not developing a website, you're not developing, any front end that's attached to it, even though you could, and I could show you that. But for the purposes of this tutorial, Remix is really all you need. So the very first thing we're going to do is we are going to go ahead and compile our token. So when you first get into Remix, you'll notice all this stuff on the side. Now I've been playing with Remix for a little bit, so I do kind of have my own contracts. But when you go in, the very first thing you're going to want to do is, let's go ahead and create a new file. You can call it whatever you want, but I just think it's simplest to do that. Okay, now the very first thing you want to do is Solidity gets mad at you if you don't have the license identifier. So you just go ahead and add that to the top. GPL 2.0. Okay, now I'm going to make this as simple as possible, and I'll explain why. When it comes to making your own token, it's pretty much, you're not reinventing the wheel, I'll say that. So the most popular way to go about it is to use something called an ERC standard. Right, now we've heard a couple different standards. There's ERC 20, there's ERC 721, there's ERC 1151 or 1155, sorry. And basically all a smart contract is, all a token is really, if I could start there, a token is strictly just code that exists on a blockchain. That's it. It's a set of instructions on how your code is supposed to run, and that's a token. Okay, so when we say something like ERC standard contracts and anything that you can use, that's what we're talking about. You have a complete set of instructions, and actually, let me go ahead and show you. For example, if your goal is to develop a BEP20 standard token, which basically is if you want to launch your token to the Binance Smart Chain, then typically people look for, they're launching a BEP20 standard, right? So you can find this in GitHub. Literally just type BEP20.sol GitHub, and it'll come up for you. And basically, if you scroll down here, what the BEP20 is it's an extension of just another flavor of the ERC20. So all of these instructions, all of this code here, now literally what we could do is I could copy and paste all this, and I can put it in here. But you're not supposed to do that. What you want to do is you have the contract that you want to use. What you're going to do is just import it. Okay. Okay, and you're done with that. So all that I did there is when I compile this contract, it's going to take everything that was here. Well, in my case, what I'm using is just straight, the straight standard ERC20. Like I said, that's not going to be a problem for you. It's just you're extending all of this code from these contracts. So basically I'm taking all of these functions and I'm packaging them in, and that's how I get my token. So what you result with is code that looks very, very clean. And I'll show you in a minute when this thing compiles, all of those functions that I just showed you are going to come along with it. Backing up real quick, I forgot to put in the Solidity version, and as you can see over here, it's just gonna set, it's just setting what your compiler version is. It needs this to know what version of Solidity to run. There's a bunch in Remix, but this caret just means anything over 0.80 is fine. So let's go ahead and make our contract now. Now, all that you need to do now that we've specified that it's an ERC20 and we've imported the proper contract, now all we need is this. Let's call it Sonic Rings. Now what this is, oops, ERC20, you're naming it and then you're providing the symbol. And then we're going to mint msg.sender. This msg.sender is your address. And the way, actually, let me write the whole thing real quick. So your constructor is taking the initial supply. So that means when you have a constructor like this, I'll show you when we deploy the token, you're going to have to provide the number of tokens, and this is where you're going to put it, right? But where does this msg.sender come from? In a second, I'll show you that. So let's go ahead and find erc20.sol GitHub. Let's see what we get. Bam, comes up. Okay, and the reason I keep coming back to these is it's just good to get used to reading the docs on these and what you're implementing. So these are the functions that you're going to be able to play with once you launch an ERC20 token. You'll be able to see the name, you'll be able to see the symbol, the decimals, total supply, balance of. It's all there. But what I'm looking for right now is the mint function. Here it is. Okay, so as we can see, the mint function, which we're pulling from this ERC20 contract, takes two parameters. It takes a address is the first parameter, and then the amount. Does that look familiar? So here, when we're calling this function, msg.sender is just the person. In this case, it's the address of the person who is deploying the contract. In that case, it would be you if you're deploying it. For the purposes of this tutorial, that would be my wallet. And then initial supply is the total amount, okay? And then there's going to be something special that we have to do with this number, but let me make sure I've got everything. All right, let's try to compile this. All right, so it compiled. Let's see what the error message was. Visibility ignored. If it's yellow, you can probably just ignore it. But it's good. It's good to go. So what we're gonna do now is we're going to go to this little icon, deploy and run transactions. Okay, and remember what I said about how this import statement works, right? So when we compiled our one contract, you see now all of these contracts that came packaged with that ERC20 are there too. You got contacts, you got IERC20 metadata, IERC20. So that import statement, you know, you want to work smarter, not harder. You're basically bringing in that entire contract, okay? And I can't stress this enough. When it comes to dealing with real money, you don't want to get too creative. You don't want to get, you know, don't try so hard to think outside of the box. A lot of times, when it comes to the Solidity contract, it should be very simple. It should be, because there's also a thing that we can get into called, it's a concept called gas optimization. If you're getting too tricky with your Solidity contracts, that's just making your gas fees go higher. It's just making those operations that much more expensive. So you want tested and proven contracts. Be creative with your implementation, with your front end, and everything else. But your Solidity contract should be simple, and this is as simple as it comes. Okay, but with your token.sol contract, we select that, make sure that's good. Down here, you'll see that there are no deployed contracts just yet. So let's go ahead and check what this deploy script does. Just to back up for a second, what this JavaScript VM does is it's basically just a virtual machine that you can test your contract with. Nothing wrong with that. You can see that with the JavaScript VM, there's a couple other options, but it's providing you a couple of accounts, all with a ton of Ether. And obviously, it's all test Ether. Nothing's going to happen. You'll be completely fine. And then there's some other options. Injected Web3 is what you will use when you want to test on different networks. So let's go ahead and do that before we actually deploy this thing. Let's see it on a real test network. Okay. So as you can see, I'm in my MetaMask wallet, and you're going to want to make sure that you have the Binance Smart Chain testnet. So you have TBMB, right? Very important. If you don't have this testnet, what you're going to do is you're going to go to chainlist.org. You're going to connect your wallet, and you're going to turn testnets on. turn testnets on, and then search Binance, and it should pop up. Connect your wallet. You see TBNB. Connect your wallet. I've already done it, but when you just go add to MetaMask, it's pretty easy. It pops up. You select allow the test network, and then you should see it in your MetaMask. What you're going to want to do then is you're going to want to go to this site, testnet.binance.org/faucet-smart. Okay, you're going to go to your MetaMask, and maybe it won't let me again, but you copy your wallet address. This is your wallet address here. Copy it in, and I just did this. I don't know if it's going to let me do it again. Okay, give me BNB, one BNB. Let's see. Okay, so it's telling me this because I literally just asked for some BNB, and I'm getting greedy. Okay, but that's all you would do. Just use your wallet address to get some test BNB. Okay. Then what you're gonna do is go to injected Web3. Now see that it's got the same wallet address as my MetaMask. Okay, and it's even reading how much Ether I have in here. So let's go ahead and deploy that contract using my real wallet address, and that's going to be that msg.sender. So you go here, and by the deploy script, you see that it requires a input. It requires a parameter. Now this is very important. I'm going to actually write it here. So whenever you are setting the initial supply, let's say we wanted 100 Sonic. What we're really saying is we want the way our initial supply is set is you have to set it in the smallest unit of Ether, which is Wei. And Wei equals 10 to the 18th power, right? So that's a lot of zeros. So if I wanted 100 Sonic, then that would be 100, 2 zeros, and then 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's going to equal 100 Sonic. Okay? So do that again. Okay, and let's go ahead and transact. Now before I press this button, what should happen is it's going to cost me gas fees in order to mint these tokens. MetaMask pops up. You see it's a contract deployment. You see how much it's going to cost you in gas fees. Let's go ahead and confirm. And it could take a little bit. Okay, and then transaction confirmed. So before we go ahead, let's take this time to go over what just happened. So transaction confirmed. I could click this and it's going to take me to Etherscan, but let's go ahead and close that and look at it in our MetaMask first, just so we get comfortable with it. So we see how much the transaction cost us. You can view this transaction on Etherscan. Or in this case, not Etherscan, sorry. This would be BSC scan because it's on the Binance test chain. Okay? Okay, so here you see your transaction hash. You see that it was successful. You see who that msg.sender was, which was my account. Created a contract for Sonic Rings, right? And it even breaks down how much your transaction costs. So just creating it cost me $4.77. Okay, so what are we looking at here when we have this contract address? This contract address is where your token resides. So you can either select the name Sonic Rings or you can select that contract address, but you see it there. And in this address is where all of the tokens that were minted. Your token address identifies exactly what it is. So token Sonic Rings. Okay. And we've deployed our contract, and that's it.